Hello, everyone. What we're going to do today is we're going to look at areas under the standard normal curve, which is what we talked about really, we began to talk about it in section 6.1, but we're going to dive into it a little further here in section 6.2. So, when we talked about the normal curve, these were our basic properties. We knew it was bell shaped, we knew that it was centered at the mean, and that as we got outside the range of 3 standard deviations to the right of the mean and 3 standard deviations to the left of the mean, it got very close to the x-axis. That's basically what we talked about with the basic properties of the normal curve. Now, if you remember, we took the z-score, the standardized variable, and we standardized this normal curve. And so we said that once we changed everything to z-scores, that it was still bell-shaped. It was still centered at the mean, but the mean in terms of z-score, remember, is 0. and it gets close to the horizontal axis outside the range of -3 to 3, and it's symmetric about 0. That's what I saw. That's kind of a review of what we talked about in section 6.1. Now here's a few other basic properties, and we talked about a few of these in the last section, but we'll delve into them a little deeper now. The total area under the curve is 1. We talked about that if you added up all the areas, you should get 1 or 100% in terms of percents. It never touches the x-axis in both directions. We talked about that. It's symmetric about 0. It should be mirrored about 0. That's part of the normal curve characteristic. And we talked about that almost all the area was between -3 and 3. We talked about that. And what separates this from a regular normal curve, remember, is that the horizontal axis is in terms of z-scores, not x. So everything on the horizontal axis will be z's, not x's. We have converted it, if you remember, using our formula. So this is what you're going to need to get used to. And this is the normal curve table, okay? And this is in the appendix of your book. I will provide these for you on tests, so you don't have to worry about bringing them with you. They are part of your formula card that came with your book, so it'd be very easy for you to look at that. Now, what you need to notice is look at the blue up there. Everything is to the left of Z. These tables will always give you the areas to the left. All these numbers in here, inside here, these all represent areas under the curve. Everything on the outside helps to represent a z-score that goes with that area under the curve. But all these areas represent to the left of our z-score. So, let's look at an example. Find the area under the normal curve that lies to the left of 1.23. So let's look at our table. And so we're wanting the one that lies to the left. We're wanting to find all this to the left of 1.23. So here's how you need to do this. 1.2 right here. Let me get a darker color. 1.2 is right here. Okay, we're at 1.23. So that's the hundred. This is the whole number in tenths place. Now we got to go over here to get the 2-3. This is our hundredths place. So you want to figure out where those meet. Well, they meet right here. So a z-score of 1.23 has an area of 0.8907 to the left of it. Now, it's important that you realize that. We're finding the area to the left, okay? The area to the left. Now, we'll talk about the area to the right here in just a minute. But it's all about being able to read this chart and being able to go over and find your z-score. Now, there are some that get a little more complicated than that, but not too bad. If you practice this enough, this should be part of the final exam and part of the class that you actually enjoy, because it's just reading charts and analyzing the data. Okay? All right, let's look at another example. Let's look at example 2. Find the area under the normal curve. Now look at what this says. To the right of 0.76. Now that's very interesting because I told you in the beginning, look at this chart. Look at this drawing here. These drawings will help remind you of this. This is all the area to the left of our z-score. So this is going to tell us, all these numbers in here are only going to tell us areas to the left. We're looking for the area to the right. All right, we'll come back to that here in just a minute. So 0.76, we'll look at 0.7, that's right there. 0.76, find out where they meet. Well, they meet right here. 0.77, 0.7764. Now, this is where it's important for you not to get ahead of yourself. That is the area to the left of 0.76. So 0.7764 is the area to the left of 0.76 of our z-score. Well, how do we find the area to the right? Well, that all goes back to the properties. Remember what we talked about. All this area under the curve is supposed to represent what? It's supposed to represent 1. So if we know that 0.7764 is to the left, if we take that number and we subtract it from 1, this will tell us the area to the right of 0.76. So the area to the right is 0.2236. So this would be the area to the right of 0.76. So we just have to subtract the area from the left from 1 to get the area to the right, okay? Because we know the whole thing represents 1. All right, hopefully that was understandable for you. And hopefully you won't make that mistake. So watch out whether it says left or right. Left, you can read straight from the table. Right, you have to subtract from 1, okay? Like we did here. Keep that in mind. All right, so now here's the tricky part. The area in between two z-scores. So we want to find this area in between. Now, here's what I know, okay? The table reads to the left. So if I just look at this part right here, that's the area to the left. That's the area to the left of where our z-score is negative 0.68. Okay? Well, if I add this to it, that's the area to the left of where z is 1.82. Now, why is that important? Well, it's kind of like working backwards. You're having to subtract these two areas that you find here to find the middle. Okay, so if you were to go in here and you were to find these areas, the area to the left of negative 0.68 would be 0.24. 0.2483. The area to the left of 1.82 would be 0.9656. Alright, now, I just gave them to you. You would, of course, use that chart like we've been using on the last two problems to find this. I just didn't put the chart on this problem. Now, to find this middle area, that's what we're trying to find, remember, is the middle part, not these two lefts. Well, to find that middle, we have to subtract. So subtract the area of 1.82 minus the area of negative 0.68. And what you end up with is this little area here cancels out from the area to the left of negative 0.68 cancels out that same area in 1.82, and we're just left with the shaded part there. So if you subtract these two, um, you should get 0.7173. So that would be the area in the middle there. Largest minus smallest there. Okay? And to put it in a better perspective for you, okay, to help you understand it a little better, here's a summarization of the first three. The first example, if you're just looking for the area to the left, you're just going to read the chart. If you're looking to letter B, if you're looking for the area to the right of the z-score, we have to subtract the area to the left from 1. And if you're looking for the area in between, it's the area to the left of the larger one minus the area to the left of the smaller one. Okay? And that will give you the area in between. So that's kind of the idea behind these tables and how you need to start being able to read them, okay? Now here's the caution I would give you. The first area given is 0.0000 for negative 3.90. That's actually not the area, but these are all rounded to 4 decimal places. So be careful. Just realize that that sometimes some of these may be exaggerated just a little bit. Just like if you were looking at the area where it's 1, which is a z-score of 3.9, that's actually, the z-score of 3.9 is actually 0.9999519, which is rounded up to 1 with our 4 decimal places. So you got to be careful. These are the two that will mainly do that for you. But as you start getting bigger, you start losing some decimal places there. So just a little word of caution. Now here's the part, it's easy to read the table going forward. Now here's the part where I want you to be able to get more proficient, and that's being able to go in reverse. So for instance, if I give you the area, I want you to find the z-score. So for instance, if you look at this particular problem, I want you to determine the z-score that has an area of 0.04 to its left. Now, that's important. That means we can read it straight from the table. If it was to the right, we would have to subtract it from 1 to read it straight from the table. Okay? So keep that in mind. So 0.04. So notice I've got it highlighted down here. If you look, if you're searching the table here, remember the areas are all these decimals in between. Look for the one that's 0.04. This is the one that's closest to 0.04. And figure out what z-score that is. Well, it's negative 1.75 if you're reading that. Negative 1.7, and then read over here for the hundredths place is 5. So that would be the z-score that has that area. So you're having to read the table kind of backwards. Now here's the problem with this. Notice how this it's fairly close. It was the closest of all of them on the table to 0.04. Okay? The closest. So that's why I chose it. But notice it's not exactly 0.04. So if it's not exactly 0.04, choose the one that's the closest. Now here's the problem with that. There are going to be times when 2 of them are equally close. So, for instance, our last example showed you what to do when the area you want is not on the table. 0.04 was not on the table. 0.0401 was. So we chose the one closest and used its z-score. Now, if the area is on the table, like it says here, if the area is on the table, just read it from the table. Use the z-score. That's kind of common sense. But here's the one I want you to pay attention to is number 2 right here. If 2 entries are equally close, all right, so suppose we were looking for 0.04 and the two entries we had were 0.3995 and 0.0405. Those are equally as close to 0.04. Okay, they're both 5/10,000ths away from 0.04. So look at what you do when you run into a case like that. We take the mean of the two z-scores. So you would find the z-score for this one, which I'm just making it up. Okay, don't write in thinking I'm doing it wrong. I'm just making it all up for you right here. Suppose this was the z-score. Suppose this was the z-score for this. So if they're equally distant from what we're looking for, we take the mean of these two z-scores. So I would add these two together and divide by 2, and 1.35 would be my z-score for 0.04. Now that's when they're equally close to the desired area that we're wanting. And you'll get an example like that here in just a moment. Alright, so now for some reason my nice math type that I use for this stuff is not working like it should. So what this should say here, this should say z sub alpha. We read that as z sub alpha. And what this is the symbol z sub alpha denotes the z-score that has an area of alpha to its right. You need to underline this. The area of alpha to its right. Okay? So what's that mean? Well, that means if we're going to read it from the table, what do we have to do? Well, we have to subtract alpha from 1 to be able to read it, to get the area to the left so that we can read it from the table. Okay? So keep that in mind. So here we go. Alright, forget this first one here. It's not on the table. When I was copying and pasting my table from the book, I cut off the last line that I needed, so forget that one. We're going to look at this other one. Z sub alpha is 0.05. Okay, so we want to figure out what z-score has an area to the right of 0.05. Well, the first things first. Take 0.05, and what we want to do is we want to subtract it from 1 and get 0.95. Now, why did we do that again? Because that's the area to the left. 0.95 is. 0.05 is the area to the right. In order to read it from the table, we have to have the area to the left. Alright, so now that we have that, we search our table for 0.95. Well, here's what's going to happen. You're going to get down here and you're going to look at this one, and you're going to look at this one. And what you're going to notice is they are equally distant from 0.95. So this is an example like we were talking about just a moment ago. So they're equally distant from 0.95. So let's look at their z-scores. Well, this is obviously 1.6 for both of them. So it's 1.64 and 1.65 when you read up the table to find out what the z-scores are. This is what we're looking at here. 1.64, 1.65 for those two areas. So remember what the rule states. If it's equally distant like it is here, we find the mean of those two z-scores, which is going to be 1.645. So the z-score that has an area of 0.05 to the right is 1.645. Okay, so hopefully that kind of shows you how to read it backwards and do the mean there. Okay, so you've got three options when you're reading backwards. You're either going to find the answer exactly on here like it is, and you're going to be good to go. Okay, you're going to select the z-score and move on in your life. Or you're going to find that there's one that's closer than any other, and you're going to select it. kind of like we did with the 0.0401 on one of our examples a moment ago. Find the one that's absolutely the closest and select that z-score. Or if you have two that are equally as close like we do here, find the two z-scores and take the mean of them, or the average of them. Okay? And that would be how you find that z-score. Alright, so last but not least, notice what we have here. We've been given this area in the middle, and so find the two z-scores that divide the area under the standard normal curve into a 0.95 middle and a 0.25, or that should say 0.025. That's a misprint on my part. 0.025. Okay? That should say 0.025. Alright, so for the area for the two outsides. Alright, so we need to find the z-score that gives us this for these areas of these two outsides. So here's what I'm going to do. The table reads from the left. So I'm going to look for this area first because that is the area from the left, and we can get that very easily. Okay, we can figure that out very easily. So let's what we need to do is take your table, and I told you the area is 0.025 from the left, and so what you need to do is read over and see what the z-score is. And so your z-score that gives you an area of 0.025 to the left is going to be negative 1.96. If you read your table, this will be a good opportunity for you to pause the video and practice reading the table to see if you got what I did. Now, since these two are symmetrical, notice, remember the properties we have here. We know they're symmetrical because they're the same, but we know these are symmetrical as well because our property says that our whole normal curve is symmetrical about 0. Because of that, I know this one. I just found this z-score is negative 1.96. I know this one is 1.96 because of it, because of the symmetry that we have with our graph. Now, if you wanted to double check that, notice this is the area to the right of 0.025. So you could subtract this out and you could get 0.975, and that would be your area to the left. And if you read your chart and go backwards, find the area that's 0.975, it's going to give you a z-score of 1.96, and you can confirm what I just told you about symmetry. Okay, so keep that in mind as you're doing these problems. Keep in mind about symmetry, and notice how important knowing whether it's from the left or to the right is. If it's for the left, we get to read it straight from the table. If it's from the right, we have to subtract that area from 1 to read it directly from the table. All right, so hopefully this has been understandable for you. This has been section 6.2.